Hey everybody, in this video I'm going to walk you through the installation steps for Apigee Hybrid 1.8. This is a new release of Apigee Hybrid where Google has removed the requirement of installing Anto Service Mesh prior to Hybrid installation. So let's go ahead and get started. I'm going to be doing this from scratch. First, I'm going to go and create a project in my Google Cloud Console. Then I'm going to jump into the Apigee documentation and we're going to follow the steps for Apigee Hybrid installation. Let's do this. All right, let's go ahead and create a project. Let's name it Miguel Hybrid Demo 123. Looks like it's not already taken, so that's good. Now let's select the billing account and hit create. Now this will take a few seconds for it to be created, so let's just give it a moment. All right, looks like it's already been created. Now let's select the project. Great. So we're in here in this project. So let's go ahead and jump into the Apigee Hybrid documentation. Just going to search for Apigee Hybrid. And in here, we can see the result documentation. So let's go in there. And this takes us to the main page for Apigee Hybrid. And there's a video here by Dino, which I recommend you watch as well. This is a great video that gives you an introduction of what is Apigee Hybrid. You can watch that later on your own. For now, let's just go straight to the documentation. And I'll just say, yes, I want to learn more. And we're here in the documentation for Apigee Hybrid 1.8. So that's what we're going to be following in this tutorial or in this walkthrough. So let's walk through this and see what we have in here. All right, so we have a high-level diagram showing us what is Apigee Hybrid. And you can see at a very high level, there's two main components. There's the management plane and then there's the runtime plane. And what we're going to be doing in this video is we're going to be setting up both of these. We're going to be setting up the management plane for an Apigee Hybrid organization, and then we're going to be installing the Apigee runtime plane on a Kubernetes cluster. This page in the documentation is really nice, actually. It explains you all of the, what are all the components in Apigee Hybrid, so you can see everything that's actually inside the runtime plane, and it tells you what each of them do. You can read more. You can read more on this on your own in the documentation. For now, let's just go ahead and jump into the installation steps. So I'm going to go here on the left side to install and click on big picture. And this is what we're going to be doing. So there are two parts, part one and part two. In part one, the prerequisites say that we need a Google Cloud project and we need gcloud CLI. We have already created the project, so we're good there. And the gcloud CLI, we already have it installed in the Cloud Shell, and since I'm just going to be using the GCP Cloud Shell, that shouldn't be an issue. So let's see what is next. And once we're done with this, then we're going to enable some APIs, create an organization. And what this means is we're creating an Apigee Hybrid organization, and then we're going to configure environments within this organization. Let's do this. So let's click here on prerequisites. We'll just go one by one through everything here on the left-hand side. So prerequisites first. We already have a Google Cloud Billing account, a project, and the gcloud CLI, as well as curl. Curl is also installed in the Cloud Shell. All right, so let's do next step, which is part one overview. Again, this is telling us the prerequisites. We're good there. Then it's telling us to enable the APIs. So this is step one. So let's go ahead and jump in there. We're going to be enabling the Apigee API, Apigee Connect API, PubSub, Cloud Resource Manager API, as well as Compute Engine and Kubernetes API. So let's do this. Let's go ahead and open a new tab and let's go to the console. And here in the console, let's activate the Cloud Shell. Great. So we have the Cloud Shell, and let's start running the commands that the documentation says to do. So gcloud.h, that's just really telling you run this command to confirm whether or not you have gcloud, which I do have. It's installed already in the Cloud Shell. and it's taking a while for some reason. I don't know. Well, there it is. It's, we have gcloud installed already. Next, it's telling us to set an environment variable with the project ID, and let's go ahead and do that. So the project ID is Miguel Hybrid Demo 123. So I'm just gonna fill this thing in here and then copy paste this, and we'll paste it in here. Perfect. And then it's asking us to run this command to enable all these APIs. So I'm just gonna go ahead and copy paste this command, come back over here, paste, and here we go. Now this will take a minute or two, so let's just wait and let the command complete. Great, so the APIs have been enabled and looks like it completed successfully. Let's go back to the documentation. Great, so all right, in here it's asking us now to run this other command to confirm that the APIs have been enabled. We can do that, or we can assume that it ran successfully. Either way, it shouldn't hurt. So, and the output looks a little bit different, but if we go through it, we should be able to see that all the APIs that we enabled, the Apigee APIs, Apigee Connect, Resource Manager, Compute, GKE, and PubSub should all be part of this list right here. So that shouldn't be an issue. Now let's go back to the documentation. And next it's asking us to create an organization. Let's jump over that section in the documentation, create an organization. So what is it that we're doing here? We already have a Google Cloud organization. This is not a Google Cloud organization. We're creating an Apigee organization, and more specifically, an Apigee hybrid organization. So let's see what this is saying. First, we need to get a token, and then we need to set a few environment variables in here. So, and then we actually run a curl command that will create the org. So seems simple enough. So let's do all these things. So we'll grab the command to get an authorization token. Let's paste it in here. Next, let's fill in this. So we need a project ID. We already have project ID environment variable set up. We also need to specify an analytics region from one of these available regions. I'm just gonna choose US Central. Let's put it in here. Look like I have some spaces. Let me remove them. And here it's specifying the runtime type. So this is what says the type of Apigee organization that we're creating. And you'll see that this is included in the curl command as the runtime type. Great, so look like we're almost there. So let me copy the environment variables. I'll paste them in here. And let's grab the curl command. And look like this is a curl command to the Apigee APIs for creating an organization. So we should be able to just copy paste this, put it in here, and we should have, after a few minutes, an Apigee hybrid organization. Let's jump over back to the documentation and see what is next. All right, so it's telling us that on a successful call, we should see this, which we did. And in this output, there is this name field, which contains the long-running operation ID. We can actually use this long-running operation ID to verify the progress of the create operation. So let's go ahead and do that. Let me grab the operation ID from here. Then let's put it in here, copy paste. And now let's run the curl command that the documentation gives us to check the status of the operation ID. And look like it's still in progress. I'm gonna run this a few more times. In your case, it may be a little bit faster or not, depends on, I guess, Google Cloud at that moment. So let's just run it a few more times and let's just wait. And once it's complete, we'll come back to this. All right, so it has been a few minutes. Let's go ahead and run that command again. Great, so looks like it's actually complete now. You can see the state says finished, and in the response, it gives us the details about the organization that we created. So here it is, the organization name, and it also gives us the runtime type that we specified, that it was hybrid. And you can also see that it says subscription type is trial, and there is an expiration date. So what does this mean? This is because we created this Apigee hybrid organization on a GCP project that is not officially entitled to run hybrid. So Apigee detects that and sets the type to trial. Now, if you don't want to use trial, you actually want to use the paid version of hybrid, then you have to go and buy one of the Apigee subscriptions. So let's go back to the documentation and let's see the next step. All right, so we have verified that the org has been created and we saw this output. Perfect. Let's move on to the next step, number 3, for creating an environment group. Now let's go ahead and create an environment group and an environment that we're gonna put in this environment group. The documentation here gives us 2 flavors or 2 ways of doing this. We have the Apigee UI and the Apigee API. For this video, let's use the Apigee UI since that's going to be a little bit faster. Let's go ahead and jump into the control plane and do that. We'll go to apigee.google.com and here's the control plane. Now, before we do anything, make sure we are in the correct organization. So let's go ahead and select that. And now we can go into the admin menu and do these changes. First, let's click on environments and go to overview. Here, we're going to create a new environment. I'm just going to call this test-env. I'm going to leave the default options and let's go ahead and create it. Next, let's go ahead and create a new group. So let's go ahead and give it a name. This is going to be the test group. Now let's edit the group and add the environment that we created for this group. Let's also specify a host name that we're going to be using for this group. I already have a domain that I have access to, so I'm going to be using that, and it's going to be test-api.miguelmendoza.demo.altostrat.com. So let's go ahead and save this, and that's it. Let's go back to the instructions now, and let's just skim this quickly. So it looks like it's the same stuff we did. We selected the organization, then went to environments, created a new environment, then went to groups, created a new environment group, added the environment to the group, and we're done. Let's move on to the next step. Let's install the hybrid runtime. So let's go on here on the left navigation and move on to the next section, part 2, the hybrid runtime setup. All right, so let's go through this page. We have one section about supported platforms, then minimum cluster configurations, cluster permissions, and prereqs. On the prereqs, it's telling us that we need an organization and an environment setup. That's already done. And we also need to have a domain name. This is the domain name that I put in the environment group, which you saw earlier. And let's see, cluster permissions. Well, what this is saying is that if I am not the cluster admin, then here's the specific permissions or roles that you need within the cluster to be able to complete the installation. I'm going to be the cluster admin, so this doesn't really matter. Next, we have the minimum cluster configuration, and we'll go back to that in a second. And finally, we have the supported platforms. This is saying like, hey, these are the different types of Kubernetes clusters where you are able to install Apigee Hybrid. For this video, we're going to be installing in a GKE cluster in Google Cloud. So that's already a supported platform, no problem there. And now let's go ahead and take a look at the minimum cluster configuration. So let's take a look at the minimum cluster configuration. What this page is saying is that we need 2 node pools in our Kubernetes cluster. First, we need a stateful node pool, and second, we need a stateless node pool. Each of these node pools needs a minimum of 3 nodes per region, and each node needs 4 CPUs and 15 gigabytes of RAM. Now it's telling us what the default name should be for each of these node pools. So we have the Apigee data node pool and the Apigee runtime node pool. These names can be changed if you want, and that's a little bit more complex to do. But for this video, we're going to keep the original names that are suggested in here. So what is the difference between these two node pools? Well, the Apigee data node pool, it's used mainly for the Cassandra pods to run, because these are pods that have stateful data and they cannot easily be restarted, whereas the stateless node pool are used for all those other pods, such as the actual message processors that could be restarted at any time, and it doesn't matter whether the data on those pods is lost. Now that we understand this, let's go back to the main documentation and move on to the next step. So that will be step number 1, create a cluster. We're going to be following the instructions for creating a GKE cluster. Now what this is saying is that first, pick a name and a region for your cluster, and then make sure that you know what are the minimum requirements for the cluster, which we already took a look at earlier, and make sure you're going to be running in a supported platform, which we know is going to be in Google Cloud GKE. So that's a supported platform. Then finally just says, hey, go ahead and create your cluster, and then it tells you add the necessary node pools to your cluster, then enable workload identity, and finally it just tells you, hey, get the credentials for the cluster that you created. So we're going to be doing all of this, but instead of using the CLI, we're going to be doing it from the GCP console. Let's go over to the Cloud Console, and in here we'll jump to GKE, and now let's go ahead and create a cluster. We'll pick a standard configuration. Let's give a name to this cluster, Miguel Hybrid Testing, and I'm gonna make this a zonal cluster just to keep things small. The region, or the zone in this case, is going to be US Central, and I think that's it for the main configuration, but you can see that it's complaining something here about networking. We'll get to that in a second. Now let's do the node pools. So out of the box, we have a default node pool, which we don't really care about. What we want is we want to create the Apigee node pool. So let's add 2 more. So now we have these 2 new node pools in here. Let's give them proper names. So this is going to be Apigee-data, and the other one is going to be Apigee-runtime. Now let's configure them appropriately. So the Apigee data node pool is going to have 3 nodes. That's correct. The Apigee runtime also going to have 3 nodes. That's correct. Now let's configure each of those nodes themselves. So each node needs a minimum of 4 CPUs and 15 gigs of RAM. So this is a good configuration. Now let's do the same thing for the other node pool. So that's 4 CPUs and 15 gigs of RAM minimum. Great. So I think this is all we need for the node pools. Now the default node pool, we don't need it, so we can go ahead and remove it. So now let's take a look at this networking error that is pointing out. And what this is saying is like, hey, you don't have a VPC network, obviously, because this is a new project, we haven't created it. So let's go ahead and create that. But let's do it in a new tab so we don't lose this configuration. All right, so here we're going to search for VPC networks and select the page. Now let's go ahead and create a new VPC network. This VPC network, I'm going to name it Apigee-net, and let's create a subnet, Apigee subnet. And let's pick the region for this subnet. This is going to be on US Central as well. Now let's pick a CIDR range for this subnet itself. I'm just going to say the same one as the example. Doesn't really matter because this is the only subnet in this entire VPC, so it should be fine. All right, now this subnet side range actually is, because this is going to be used for the cluster, this is technically going to limit or determine how much the cluster will be able to scale, because there will be VMs created in this subnet, and the more IPs, the more VMs you can create. All right, so let's turn on private Google access on, and let's select the default firewall rules that it suggests, and I think that will be all. So let's click done in here and let's create it. Now this will take a few seconds, and once it's done, we can go back to the Kubernetes page and continue over there. All right, so the VPC network has been created. Now we should be able to come back to the GKE page and refresh this, or actually just type Apigee net, and look like it automatically detects it. So we select the network, let's select the subnet, and we're gonna say that this is a public cluster. Now this is important. If you do a private cluster, those VMs that are used for the cluster, they're not going to have external IPs, and it's going to be more difficult for you and others to access the cluster, and also the VMs will not have connectivity to the internet. So to make things easier, I'm just going to pick public cluster, and we'll use that. Now, before we actually click create, I need to modify a few of the organization policies in this project, because I know already, I have tried this before, that the VMs for this Kubernetes cluster will not come up unless I modify those organization policies. So let's jump back to the Cloud Console in a new tab and make those changes. All right, so let's go back to the console and let's search for organization policies and jump to that page. Now in here, first policy or constraint that we're going to modify is the one for allowing VMs to come up with an external IP address. So here's the name, it's compute-VM external IP access. Now what is this policy? Well, this policy, it's basically saying when a VM comes up in your project, whether it's allowed to have an external IP address or not. Now, because we're spinning up a public GKE cluster, that VM or those VMs will have external IP addresses. So we need to modify this policy. So let's go ahead and edit. We're going to customize it and replace, and we're going to say that yes, we're going to allow VMs to come up with external IP address in this project. All right, so that's one down. Now there's two more that I know of. Another one is called require OS login, and we're also going to disable this one for this project. So we're gonna say enforcement is off. It's done. And so now you can see it says not enforced. Save this, not enforced. And finally, let's modify the last policy, which is require shielded VMs. So let's select the policy. Now let's edit the policy, and we're also going to customize it and say this is not enforced on this project, and save this. And I think we're done from the point of view of modifying policies. So let's go ahead and go back to the cluster page. So back here, let's go ahead and review all the settings for the cluster before we click on the create button. So we gave it a name. We picked a zone for the cluster. We specified that we want two node pools, Apigee data and Apigee runtime. For each node pool, we specified that we want 3 nodes, and each of the nodes, it's a configuration with 4 CPUs and 16 gigs of RAM. And finally, for the networking section, I'm picking up the VPC network that we just created with the subnet within that network. And we're saying, hey, this is a public cluster. The pod cited range and the service cited range are automatically selected by Kubernetes. These two ranges will actually be added as secondary cited ranges to the existing subnet automatically. And one more thing we need to add is under security, we need to enable workload identity as the instructions require. So let's select this and let's go ahead and create the cluster. Now this will take maybe like between 5 and 10 minutes. So just wait here and we'll come back once it's done. So the cluster has been created and it's in a healthy state. Now let's go ahead and connect to it. All right, so we'll click connect and it gives us the gcloud command that we can use to connect to this cluster. So let's copy this and we'll open a cloud console or the cloud shell, and within the cloud shell we'll connect to the cluster. Let's paste the command. Yes, I authorize this. And look like it successfully retrieved the credentials. Now let's just run a simple kubectl command to verify that it's actually connected. So we can do kubectl get pods-a, and it lists all the pods in this Kubernetes cluster and everything seems to be running. So looks like we're all good. We should now be able to move on to the next step. So let's go back over to the documentation and jump over to the next step, which is install cert-manager. So what is cert-manager and why do we need it? Cert-manager is a Kubernetes operator that brings support for creating certificates all within a Kubernetes environment. The way it works is that certificates are created as custom resources in Kubernetes. Now, why do we need it? Apigee has internal components that communicate between each other. Now, this communication needs to be secure, so Apigee uses cert-manager to issue certificates that are used for these internal communications. Let's go ahead and install it. So let's copy the command. Now we'll go to the cluster and we'll paste this command. And all this is going to do is going to grab the cert-manager files from the GitHub repo and apply them on the cluster. And looks like it's all being created, no problems, and looked like it was successful. So now let's go back to the documentation, and next we can run this kubectl command to verify that cert-manager has been installed and is running correctly. Cool. So looks like we have all the components installed and running correctly. So I think we're good in this step. Let's go ahead and move on to the next step in the installation instructions. All right, so we finally get to the interesting bits, which is the actual Apigee hybrid installation. In this step, we're going to first download the apigeectl or apigeectl tool. This is what we're going to be using to install hybrid, and then we're going to set up a directory structure that we're going to be using to organize all the files necessary for the installation. So let's actually go ahead and do it. First, we're going to set an environment variable to hold the version of the installer that we want to use. What this command is doing is actually going to a GitHub repo and grabbing the latest version number that is available. So let's go ahead and do that. All right, now let's print it. And we have version 1.8 0.0. Now this matches exactly what the documentation has, but in your case you may be doing or following these instructions in the future, and you may have a slightly different version like 1.8.2 or something like that. It doesn't matter, as long as you're in 1.8 you should still be able to follow these instructions. Next, let's go ahead and download the tarball that contains the apigeectl installer. All right, so let's grab it. All right, so the tarball has been downloaded to my file system. Now, the next step wants us to extract this tarball to what it calls a base directory. This base directory is going to contain all of the Apigee configuration files, and this is the first thing we're going to be putting in there. So let's go ahead and create this base directory. I'm going to call it hybrid base, and we're going to run this command to extract the tarball. So the directory is going to be hybrid base, and the file name, it's basically the tarball that we downloaded minus the extension, so just this part right here. All right, so I'll put it in, and we should be able to just copy and paste this and run it. Perfect. So it was extracted. Now if we go into the hybrid base directory, we should see that we have the apigeectl directory or apigeectl in there. So let's go ahead and move on to the next step. All right, so next it wants us to rename this directory and just call it apigeectl. So let's do that. So I'm going to move this directory and just call it apigeectl, and that should be good. All right, so now it says go into the new apigeectl directory. So let's go into the apigeectl directory and run the actual command to verify the version that the actual installer has. So let's double check that we're in here, and you can see we have an executable for apigeectl. So we should be able to run apigeectl-version, and great. So we do have 1.8. This is all good. Now it wants us to create this environment variable called apigeectl home. This is going to be used later for other parts of this step number 3. So let's go ahead and set it up. Great, and let's print it, apigeectl home, and this is the absolute path to the apigeectl home. Basically, it's just saying the apigeectl tool exists within this directory. Now let's go back to the instructions. And we're going to be setting up a directory structure within the hybrid base directory to contain other files that are going to be using that we're going to be using during the installation. So first, we're going to go back to the base directory and make a new directory in there called hybrid files, and we're going to export that hybrid files as a new environment variable. So let's go ahead and do that. So we go one level up. Now we're in the base directory, and in here we're making a new directory called hybrid files, and we're going into hybrid files and creating a new environment variable called hybrid files pointing to this directory. All right, so I think that should be good for this step. Let's go back to the instructions. Now, within the hybrid files directory, we're going to be creating a couple more directories as well as a few symbolic links to pointing to directories that come from the apigeectl home directory. So let's go ahead and do that. So first we'll create these two new directories for overrides and certs. Next, we're going to create the symbolic links, which I have in here. So let's copy this. And make sure you're doing this from within the hybrid files directory. Perfect. So this should be all that is needed. So let's take a look. So we have the two new directories, certs and overrides, and the other ones are symbolic links. So I think we should be good for this step. Let's see. All right, there's nothing else, and we can move on to the next step, which is setting up service accounts. So why are these service accounts needed? Well, the Apigee components, the actual runtime, those are running in a Kubernetes cluster, and that cluster could be located anywhere. It could be on-prem, or it could be on another cloud, and those components themselves need to securely access services that are running in the GCP project associated with your Apigee organization. So these service accounts are actually the identity that is used for each one of the Apigee internal components. Within the tarball that we extracted earlier, there is a tool called Create Service Account. We're going to be using this tool to basically create the service accounts. Now the tool gives us two flavors or two choices to do this. We can do the prod or the non-prod way of doing it. The non-prod basically creates a single service account and assigns all the necessary roles to that service account, whereas the prod version creates individual service accounts for each component, and each of those service accounts only has the roles needed for that component. Now, in addition to creating the service account and assigning the proper roles, the tool will also create a service account key and will download that key. This is not always possible to do in every GCP organization because there may be policies that restrict this. And this is in fact the case for my GCP organization. So I'm going to modify that policy and allow the tool to create a key and download that. So let's go ahead and do that in another tab. Let's search for the policy, which is disable service account key creation. And we're going to go ahead and modify this policy so that it is not enforced within this project. So enforcement is off. Let's save this. And that should be all that is needed. So we can go back now to the instructions and run this command so that we can create the service account that we're going to be using. And let's run the command. And right away, the command is asking us to confirm our selection. So yes, this is the project I want to use, and I want to proceed. And let's authorize. Perfect. Looks like everything was successful and the service account was created. If we look inside the hybrid files directory, we should now see that there is a service accounts directory, and within this new service accounts directory, we have the key for the service account that the tool downloaded. We're going to be referring to this file later on in another step, but for now, let's go back to the instructions. All right, so the instructions basically just ask us to do what we already did. So let's move on to the next step, which is create TLS certificates. In this step, we're only going to create one certificate and the associated key for it. So what is this certificate for? Well, the Apigee runtime, when it receives an API call, it needs to terminate a TLS connection. that is what this certificate is going to be used for. For the purpose of this video, it's going to be a self-signed cert because this is a non-production system. However, if you're doing this for production, you want to have a proper certificate that is signed by a well-known certificate authority. So why is it that I am creating only one certificate and key? Well, if you remember earlier when we configured the control plane, we created a single environment and a single environment group. And for this environment group, we have this domain name. Now, if we had multiple environment groups, we would need one certificate and key pair for every environment group. Hopefully that makes sense. So let's go back to the instructions and create the certificate that's going to be used for this environment group. Let's review the instructions. So it's asking me to set up this domain environment variable. Looked like I should have set it up earlier, but I may have missed that step. Then we create the certificate and key, and then we inspect it. So let's do that. All right, so we had the domain environment variable. Next, let's actually run the OpenSSL command to create the certificate and the key. Looked like it worked. Now let's go ahead and inspect the output. So we should see that the new key and the new certificate have been created. And there we go, both files are there, the keystore.key and keystore.pem. So I think we're good now. Let's go ahead and move on to the next step in the instructions. Here, we're going to be creating a configuration file that we're going to be using later as the input to the apigeectl tool when we do the installation. This file is usually referred to as the overrides.yaml. Why is this the case? Well, because when you specify all the values that are used for the configuration, you're technically overriding the default values that Apigee has in the templates that ship with the installer. Let's grab the non-prod example that's in here. And now let's jumping into the Cloud Shell. And I'm going to be using the editor that's available in the Cloud Shell. And now here within hybrid base, this is the directory we created earlier. Let's expand this and we can see that it's got this apigeectl hybrid files, and within the overrides directory, we're going to create a new file and it's going to be overrides.yaml. Perfect. Now let's paste the configuration, and now we're going to go over each of these values that we're going to fill in here, and I'm going to try to explain what they are. First, we have the region. This is the analytics region that we chose when we created the Apigee organization, and that was US Central 1. Next, we had the project ID. This is the project ID where the Apigee organization was created, and we can copy here from the URL. All right, so that should be this. Next, we have the name of the cluster. We also have it in here in the URL. This is the Kubernetes cluster that I created. So let's put it in here. Then it's asking us to put the cluster location. This is the region where we created the cluster itself. So in this case, it's a zonal cluster, but we can just give it the region name. Finally, we have the organization name, which in this case is really the same as the project ID. I don't think this can ever be different. And this is it for this first set of parameters. I'm going to skip instance ID. We'll come back to this one in a second. Next, we have virtual host. So virtual host, basically they need to map to the environment groups that we have. So we only have one environment group that we created. So I'm just gonna grab the name from here, and then we can paste it in here. So technically you can see here, this is an array of virtual hosts. So if you have more than one environment group, you're going to have an array of virtual host. Then we have this selector. We don't have to modify this. This is out of the box. That's the label that the Apigee Ingress gateway is going to have. So we leave that as is. Then we have the certificates. Now remember those certificates we created earlier? Well, this is what this is referring to, and they were called keystore.pem and keystore.key. So I'm just going to modify this. And notice that these paths are relative to the hybrid files directory. So when we run the tool, it needs to be relative to this. And all right, so let's keep going. Next, let's get to the Ingress gateways. This is also an array, and we're actually going to provide only a single Ingress gateway. Behind the scenes, an Ingress gateway is really just a deployment of Istio gateways, which themselves are actually Envoy instances. And this is asking us, hey, just give a name for this deployment. So I'm going to call this Apigee Ingress, and we can specify a minimum of 2 pods and maximum of 10 pods. Now, why would you have more than one Ingress gateway? Well, there may be use cases where you would want to have traffic isolation where maybe 2 environment groups use 2 completely different Ingress gateways and the traffic is separated between them. That could be a use case. It's really up to you. For our case, 1 Ingress gateway is enough. Next, we have the service annotations and also the service load balancer IP. What this is saying is that, hey, if you want the installer to go ahead and create a Kubernetes service for you, please tell us what annotations you want to use on that service and also what load balancer IP you want to use if you already reserved one. Now, I don't think this is working right now because there's a reference in here to a non-issue. So it looks like this is not working. So I'm just not going to provide either of these 2 values. And instead, we're going to configure a Kubernetes service manually at the end. So let's go ahead and remove this. Next, we have the environment array. Now, this also needs to match to the environments that you have in your control plane. So remember earlier, we created a single environment. So if we go back to overview, we can see that we have the test EMB environment that we created. So that's what we're going to be putting in there. So let's just put it test EMB. And now it's asking us to put the service accounts or the path to the file that contains the service account that we created earlier. Now remember, we created only a single service account, and actually it was in this directory that it's giving us as an example. The only difference is that we need to put the project ID in here. So let's just grab the example and paste it in, and let's fill in the project ID. And that should be correct. Now we can actually check this. It should exist within the hybrid files directory. So if we do ls/la hybrid base hybrid files, we should see that the file is actually there. So this is correct. Now let's go ahead and paste the same file for all the other components. You can read more on the Apigee documentation, what each of these components are, and each of them basically do different things. For example, this UDCA is the Universal Data Collection Agent, and then we have the Synchronizer, the MART, and a few others. All right, so now all of this internal components of the runtime will use a single service account, and I think that is all. We don't have to configure anything else. So we're ready to move on to the next step. Actually, one more thing I almost forgot. Let's go back and set the instance ID. So what is this instance ID? This is a unique identifier for the Apigee runtime instance. So why do we need one at all? Now imagine that you spin up another Kubernetes cluster in another region. That Kubernetes cluster is also going to have an Apigee runtime instance, which needs to have its own ID that is different from this one. So for now, let's go ahead and name this one. Let's say Miguel US Central 1 instance. And I think that should be good. Let's jump back to the instructions. and move to the next step. In this step, we're going to be allowing the Apigee Synchronizer component to access the APIs in the Apigee control plane. Remember, the Synchronizer is a component that will be running within the Apigee runtime. And this component is responsible for fetching configuration and making sure that the Cassandra database is up to date with the data that we have in the control plane. So how do we go about doing this? Well, remember, the Synchronizer component has its own identity, which is that service account that we created earlier. We need to tell the control plane, hey, this specific service account should have access to the control plane APIs for the purpose of synchronization. And in order to perform this operation, we ourselves need to have the role of Apigee administrator within this project. So first, let's go ahead and make sure that that is the case. So I'm going to go on a new tab, and in the console, we're going to check in IAM to make sure that within this project, we have the correct role. Great, so this is IAM, and my user is this one here, and I don't have the role of Apigee administrator, so I'm going to give myself that role. Here it is, Apigee organization admin, and let's save this, and I should be good to go from that point of view. Now let's go back into the instructions. Great. So now that we have the role of Apigee administrator, we need to actually run the command to give the synchronizer access to the control plane. To do this, the instructions first wants us to go and list the service accounts and filter by this string, which is Apigee non-prod. Actually, if we go back to the IAM page, we can see that that service account is already there, so we don't really need to run that gcl command. We can see this is the email for the service account that we're going to be using. So now that we know the service account is there, we should be able to run this curl command. So let's fill in the information in here. So this is going to be the organization name, which is the same as my GCP project. So let's go ahead and copy that. We'll fill it in here, and it automatically fills in both places. And in order to run the curl command, you can see that it has this environment variable for an authorization token. So we're also going to need to run this command in here to get an access token. All right, so let's copy this and jump back in here into the terminal, and we can go back to this old terminal that we were using. Now let's go ahead and get a token. Now that we have the token, we should be able to run the command to enable the synchronizer access. All right, so let's go ahead and paste it. And perfect, it looks like it worked. You can see it replied with a response that includes the service account that we told it that it should have access. All right, and if we actually want to verify it again, we can run this order curl command, and we'll see that it's really the same response. Perfect. So we got the same response, which means it actually took effect. Now, you may be asking yourself, why is this an array of identities? Well, imagine if you were to install Apigee Hybrid, maybe in a different cluster in another region, those hybrid components could be using a different service account as its identity. And those hybrid components also will need to access the control plane APIs for this organization, which is why we allow you to specify multiple identities. All right, so let's go back into the instructions. And finally, we're going to be doing the Apigee Hybrid runtime installation. There are two distinct operations that we're going to be using to install Hybrid. The first one is the init command, and the second one is the apply command. Each of these have different purpose. The init command, what it does is that it creates Kubernetes custom resource definitions for Apigee Hybrid, and it also spins up an Apigee Hybrid operator. the second command, what it does is that it creates the actual custom resources for Apigee Hybrid, and then the operator spins up all the necessary Kubernetes resources to create the Apigee runtime. So let's go ahead and run this. So first things first, let's make sure that kubectl is still working. So we'll go into the hybrid files directory. Actually, we are already in here. So let's just go ahead and run kubectl get pods -a, and it looks like it is working. We see all the pods in this cluster. Hybrid is not installed yet. So this is all the pods from the Kubernetes system itself. So let's go back to the instructions, and we're going to be running the first command, which is basically the init command, but with a dry run flag. This means that it's only going to check to make sure that all the stuff that we have in the override looks okay, but it's not actually going to do anything. So let's go ahead and do the dry run. All right, let me clear the screen and paste this. And great, so it looks like it's checking the files that we have and specifically looking at the overrides and making sure that it's able to apply these overrides files to all the templates that it has. And looks like it completed successfully, so we can go ahead and come to the next step. Now that the dry run completed successfully, let's go ahead and actually run the init command. And looks like it's all going fine, so we'll just let it run, and once it's complete, we'll come back to this. Perfect, so it looks like it completed. Now let's clear the screen and go back to the instructions. So we have a few commands here that we can use to verify whether the init operation was successful or not. First, we have a check ready command. Let's go ahead and run this. And it looks like everything is ready, so we're all good there. Let's go to the next command. Here we're going to get all the pods in the Apigee system namespace. Let's go ahead and run this. And it looks like we have a job that has already completed, as well as a pod, which is the Apigee controller manager. I believe this is the actual Apigee hybrid operator, and we can see that it's running, so we're all good there. Next, let's get the pods in the Apigee namespace. Cool. And also here we have a couple more pods, which are the Apigee Ingress gateway manager, and both of these are up and running. I believe these ones are the equivalent of Istio-D for Apigee Hybrid in 1.8. I don't think this was there in before 1.8, and because 1.8 removed the requirement to have ASM already installed, there needs to be something to do the job that Istio-D was doing before. So I think this is what this is doing. All right, so I think we're done with the init step. Let's go back to the instructions and move on to the apply. All right, so just as before, we have the apply command with a dry run followed by the actual command itself, then a check ready. So let's do the dry run. Great, so it looks like it's running. And remember, the dry run is not actually checking that things will work. It's just making sure that the values that you provide in the override YAMLs do not generate any errors when they get applied to the templates that come with the installer. So looks like this was good. Let's go back and actually grab the apply command and run it. Great, the apply command completed without errors. Next, let's go ahead and grab the check ready command. So you can see that it says ready check failed. This does not mean that the installation actually failed. It just means that the components are still coming up. If we want, we can actually use kubectl and watch the progress as all of these components come up. So we can run kubectl get pods within the Apigee namespace. And you can see some of them are still running, some of them have already completed, and this will take actually a few minutes before the entire system is up. So what I'm going to do, I'm just going to run a watch command and we'll see the pods as they come up. Alright, so it's been about almost 10 minutes since I ran the apply command, and it looks like all the jobs have completed and all the pods are in running state and looks like they are all ready. So I think this means that the cluster itself, or the Apigee runtime, is ready to go. We can see that one of the pods restarted a couple of times, and that's the nature of Kubernetes. Sometimes pods will restart, but eventually it came up successfully and it's running. So let's kill the watch command and we can go ahead and rerun the check ready command. And let's see what it says. Great. So you can see now that the check ready command says all containers are ready. So we know we are good to go. So I think this is it. We have successfully installed Apigee Hybrid. Let's go back to the instructions. And yes, this is it. Congratulations, you have successfully installed and configured the Apigee Hybrid runtime plane. Now it's time to connect it to the outside world. So let's go to the next step and do that. How is this going to work? We have two choices. We can create a custom Kubernetes service, or we can use the default Kubernetes service. What is this default Kubernetes service? Let me explain. If we go to the command line and we do kubectl get service within the Apigee namespace, we should see that there is a service in here of type load balancer that has an external IP address. This is the default Kubernetes service that the documentation is referring to. This is a fully working load balancer. If we go to the GCP console, we will see that there is an actual L4 load balancer that is properly configured. And we could actually use this to send API traffic into the Apigee runtime. But we don't really want to do this, and let me explain why. What's going to happen later when you upgrade to the next version of Apigee Hybrid? Well, this Ingress, or this Kubernetes service, is going to get deleted and you're going to lose this IP address because this is an ephemeral IP address. And this is not good for continuity, because then you're going to have a new IP address that you're going to have to update in the DNS records, and you're going to lose access for some time. Now, instead of using the default Kubernetes service, there's a better way of doing it, which is to create your own custom Kubernetes service with a static IP address that you manage outside of the hybrid installation. So now that you understand this, let's go back to the documentation and follow the instructions for creating a custom Kubernetes service. Let's grab this sample YAML and copy it over to the Cloud Shell editor so we can modify it over there. So let's create a new file. I'm going to call the new file service.yaml, and let's paste the content. Now let's go over every field in here and I will try to explain what they all mean. So first, it's the name. So we need to give a name to this service. So I'm just going to call this the Apigee Ingress service, and it's going to be in the Apigee namespace. So that's all good. Then we have the ports. This first port is used for health checks, and the second port, 443, is used for actual API traffic. Next, we have the selector area. There's 3 labels in here that are used for selectors. What does this selector mean? Behind the scenes, there are actual Kubernetes pods that are running the Apigee Ingress gateway. So the selector, all is saying is point this service to the pods that have the matching labels. And the first label that is provided in here, this is set by Apigee, so we're not going to modify this, we're going to keep it as is. The second label, this is one that we provided when we created the overrides file. So remember, in the overrides file, in the Ingress gateways, we gave a name to each gateway. So this is what that label is. So let's go ahead and copy that and put it in here. And finally, the org name is the same as our GCP project. Great, so we're almost there. We have everything except the load balancer IP address. And we're gonna get to this in a second, but first, let's actually test these labels and see that it actually works the way I just explained. First, let's run a kubectl command to list all the pods within the Apigee namespace. And you can see here, this is every single pod in the namespace. Now, let's incrementally filter this output using the labels specified in here. So we'll modify the kubectl command and pass -l, and let's provide the first label, which is app equals to Apigee Ingress Gateway. And you can see here already, it filtered it down to just the 2 pods for the Apigee Ingress Gateway. But this is not necessarily enough. What if you have multiple Ingress gateways within this hybrid runtime? Well, that's where the Ingress name comes in. So we can add that to the filter list. And we'll specify the name of the ingress. And you can see that still works. It just gives us those 2 pods. Finally, we have the org label. Why is the org label needed? Well, the Apigee runtime can be shared by multiple orgs, so we need to specify which org we want to target. So let's add that as well. And you can see that it still works as expected. Now, let's set up the load balancer IP address. Remember, as I explained earlier, the main point of setting up a custom Kubernetes service is so that we can have a static IP address as opposed to an ephemeral IP address. So to get a static IP address, we'll go to the Cloud Console and reserve one. In here, we'll go to IP addresses. And let's click on Reserve External Static IP Address. I'm going to name this Apigee Ingress IP. It's an IPv4 address and type is regional, with the region matching that of our Kubernetes cluster. Great, so we have a new IP address. Now let's copy this and bring it back into the file. And I think this is it. We should be good to go now with this service file. Let's go back into the instructions. Next, we're going to actually apply this service file. So I'm just going to run this command right here. And the file name that we gave it was service.yaml. So let's go ahead and copy this. And we can go back to the original terminal that we were using. And we are already in the correct directory. So we can just run kubectl apply. And it looks like it worked correctly. Now let's go back into the instructions. It's asking us to just run kubectl get service to verify that things work correctly. So let's do that. So here we have the services within the Apigee namespace, and it looks like the new service that we created, the Apigee Ingress service, it is still coming up as it's in pending state. And we can actually go into the Cloud Console and see that a load balancer is being spun up for this new service. So let's go ahead and do that. We'll go to load balancers. And we can see here there's actually two load balancers. This one down here is the one from the default Kubernetes service, and this one is the new one that we just created. And we should be able to see that this IP address actually matches the IP address that we reserved. And that is correct. So looks like everything is good here from the point of view of the load balancer. So let's go back into the terminal and check the status of the service again. And looks like it now actually got the IP address. So everything is in order. Now let's go back into the instructions. Next, we're going to test the health of the Ingress gateway through the new load balancer that we created using this curl command right here. So let me explain what's happening. Here with curl, we're passing a user agent header pretending that it's a Google Cloud Health Check. And we're also specifying the domain name. This is the domain name of the environment group that we created, as well as we're passing this flag in here, which is basically telling curl, hey, for this domain name, use this IP address. This is needed because we don't have a DNS record yet for that domain name. So we have to tell curl that, hey, don't do DNS resolution for this. Instead, use this IP address that I'm going to give you. Let's fill in these values. First, let's grab the domain. So we can go to the Apigee control plane and copy the host name for the environment group. We'll fill it in right here. Next, let's get the Ingress IP address. We can grab this from the output of this command. We can see the IP address is right here. And let's fill it in. And I think this is it. So we should be able to just copy this and paste it in the terminal. And great, we can see it actually output Apigee Ingress is healthy. So looks like it is working as expected. So let's go back to the documentation and look at the very last step. Here, we're going to do two things. First, we're going to be using the Apigee UI to create a new reverse proxy, and we're going to call it my proxy and point it to this URL right here. Then we're going to use a similar mechanism that we used in the previous step to call this proxy and verify that the API traffic is actually working. So let's go ahead and do it. Let's jump into the Apigee UI. So we can come into the develop menu under API proxies and create a new proxy. This is a reverse proxy. We call it my proxy, and the URL is going to be this. So we can click next, leave everything here as defaults, click next, and let's go ahead and create it. So the proxy was created. Now let's make sure we deploy it. So we're going to deploy it to the test environment, and let's click on deploy. Yes, I want to confirm. Now it may take a minute or two for the deployment to complete, so let's wait here. So the proxy has been deployed. Now let's go back to the instructions. And we can actually do step number 2, which is call the API proxy. Let's fill in these variables right here. So first we need to have the Ingress IP address Again, this is the IP address of the load balancer, so we can grab that from the same place we grabbed it before. So let's do a kubectl get service and Apigee, and we can see here the Ingress service. So let's grab the IP address. We'll put it right here, and we also specify the port number. In this case, port number is 443. Finally, we specified the domain name itself, which is the domain name for the environment group. So we should be able to grab that also from the group. So let's go ahead. All right, so we have the domain name, the IP address. I think we have everything. So let's go ahead and copy these values. Let's go back to the terminal. And finally, let's run the curl command. And great, we got hello guest. This means it actually worked. Now, I don't like that we're having to trick curl into doing DNS resolution with the result flag. Instead, let's go ahead and actually register a DNS A record for this domain name, pointing to the IP address of the load balancer. I have already a cloud DNS zone for the parent domain name in another project. So let's go to that project and register the A record. Let me search for Cloud DNS. And here's the DNS zone. So we're going to add a new record. This is going to be test API, and the IP address is going to be the IP address of the load balancer. So let's go ahead and create the record. And great, so the record is now there, and usually it will take a minute or so for it to propagate, but within the Google Cloud name service is actually much faster, so I think we can start using it right away. Before we use it, let's do an NS lookup to verify that it actually has propagated. So we'll put the domain name, and look like that is the case. We got a response with the actual IP address of the load balancer. So we should be able to simply run curl and put the domain name /myproxy. And awesome, we also got a response. This is amazing. We now have a fully working Apigee hybrid runtime, and we did this from scratch. We created a project and everything after that to get to this point. Well, folks, this is it. If this video was useful to you, don't forget to leave a like and subscribe, and I'll see you in the next one.